for inviting me. My name is Camilla Moster, and I'm currently heading a department in BKK that's called Mobile Energy. Previous to this job, I was a project manager within different innovation projects at BKK. And one of these innovation projects ended up as this new department within electrification. So I'm going to tell you a bit about that story and about the road towards electrification of construction sites. And on this page, you can also see our new name and logo, Eviny. So BKK will, from 2022, have this new name and brand. So this is just a sneak peek of that. I'm sure you're all familiar with BKK, but just very briefly about us. We are the largest renewable energy company in Western Norway, and we are a large hydropower production company with a 100-year tradition for producing hydropower. We have 38 hydropower plants along the coast. We also have a large grid company. We are a large operator of fast chargers and super fast chargers. We have a district heating company within BKK and telecom companies, so we're a very broad energy company. 2025 is the year that several large municipalities in Norway will have requirements for 100% emission-free construction sites. So this is only 4 years to go, and it's still a long way, and lots of change that needs to happen within this industry. We in BKK want to be a part of this journey and to drive this innovation process and to drive the change towards zero emission technology. And we have developed a concept and an offering that we hope can achieve this goal. So what is a zero emission construction site? We're talking about the direct activities and emissions within the frame of a construction site. So everything, all machinery and all equipment running within the fence have to be run on emission-free technology. And today, most of this equipment will then be available at battery or cable electric technology. So this is a nice drawing of or an illustration of a construction site or a building site. So you have a grid connection into the construction site. This is often put up temporarily for the construction phase. Then we can use larger battery containers in parallel with the grid to support the grid. Then we have charging infrastructure, both slow or normal chargers for vehicles and for night charging of machineries, and fast chargers for charging up battery-driven excavators and other machinery. Some equipment such as cranes and concrete delivery can be used or can have a cabled power. Then we also look into using the district heating solutions for heating and drying of the buildings. And from 2025, this will be requirements in many of the large municipalities in Norway. And already today, we see that they ask for this and set requirements for emission reduction within the construction site. But this market is largely driven by the government. BKK have several R&D projects ongoing now, along with different collaborators in the value chain. The first project we have is a Pilot E project called Energy Partner for Zero Emission Construction Sites. So Pilot E is a joint collaboration between Innovation Norge, Enova, and the Forskningsrådet. So this started 1.5 years ago, and we gathered with 9 partners along the value chain. And the goal of this project is to test different types of equipment and batteries in real life scenarios in order to get learnings from using the equipment, and to get the data and input on energy and efficiency and power need for different types of equipment. We also work in this project together with the grid company to improve and automate parts of the grid connection process. And we're developing a model that can calculate the energy and power need for a zero emission construction site. So this has been a great innovation project with very close collaboration to different companies, such as the constructors, the housing, the owners of the projects, the distributors of machineries, a grid company, and so on. We have an R&D project together with Bergen Municipality, where we are working as the energy partner, and together with them we are developing the framework for zero emission construction sites in the municipality. And they have also two pilot projects pointed out. So one is a kindergarten that's being built, and one is a hospital. And then we have an ANOVA project called Mobile Charging Infrastructure for Zero Emission Construction Sites. So this is more focused on the larger construction areas, so where you're building roads or digging for pipes at long stretches, and you need to develop a mobile charging infrastructure that can be moved around in the construction site to provide charging for the electrical excavators. And this is also a 3-year project started earlier this year, and we work closely with the machine entrepreneurs to test solutions with them. And we also work on developing a digital twin for the electrical infrastructure and to get all of this connected IT and data-wise. Yeah, so this learning along the value chain and closely with our collaborators has been very good. It's enabled us to develop and test equipment and test solutions very quickly. So it's been a great fun and learning experience for us. One of the kind of key goals is to look at how we can use battery technology in order to avoid building unnecessary grid capacity. This is just an illustration of the power demand during the different phases of a construction process. So you can see here the peak demand, which varies largely between the different phases of a construction process, and will also vary a lot if you zoom into one day. And this dimensioning peak power will in most cases be much higher during the construction phase than during the operation phase of the house or whatever you're building. Our aim is to look into how we can reduce necessary building of grid connection with reducing the peak power with battery technology. And in a traditional construction site, you would usually have the highest peak power during these phases when you have cranes and heating and other equipment. But now when you also put requirements for electrical excavators and heavy machineries, zero emission, you could have the highest peak demands in the earliest days of the construction process when you have groundwork. And this gives an even larger challenge in terms of giving the needed infrastructure to the construction sites. So it's mainly 3 factors that impact the efficiency that you can have on a zero emission construction site. Firstly, is the grid capacity you have at the specific location. So you find construction sites all over our country, even in the most rural areas. And what you have in the surrounding power grid in terms of both capacity and voltage is limiting what you can achieve within the construction site. So here you can support the grid if you have low capacity or weak grid with battery technology. Second is the charging infrastructure. So if you have a AC or DC charging available, and what types of fast charger you have will determine how fast you can charge up machineries and vehicles at sites. And then you have the charging intake on the machine, which is often not standardized, but we work towards getting the standards from the car industry also in the machine side. But this will determine if you can utilize all you have available in the grid and within your charge infrastructure. So I will here explain a bit about the different charge profiles for different types of charging infrastructure. So in this first example here, you can see a charging profile for 1 day. So these are the hours of the day. And here is approximately 10-ton battery electric excavators. So we have 2 excavators charging during the night, and on this normal charging can provide up to 22 kilowatt charging, so 44 in total. And then you would have a small charging break during lunch hour, and then you would charge during night again. So in this case, 44 is the dimensioning peak power. If you have fast charging available, you would still slow charge during the night, but then you would have a fast charging break during the day. And this would often be the required infrastructure or charging speed in order to get full activity on an excavator during a day. So if the battery on the machine is empty within 4 hours, you will have to fast charge in order to use it the rest of the day. So as you can see, if you have to fast charge 2 excavators at the same time, you would reach up to 300 kilowatts in peak power in this case. Looking at the whole construction process for a 1-year building process for a large building, this is an example that we dimensioned. At this example, you will have the highest peak powers during the first phase, where you have 300 kilowatts in the highest peak. Then the peak power varies in the different phases, and in the operations phase, it's as low as 25 kilowatt in this case. On the bottom, you see different types of machineries and equipment that can be used without emissions in this case. Digging into 1 day of this first phase, so we know at this stage of the construction phase, you can see here the different equipment used in 1 day and the power demand during the day. So we have night charging of several battery-driven machines. Then the peak goes down when you plug out the charger and use the equipment. And you have a very high peak at the middle of the day when you fast charge. So you have parallel charging during the day. This point here for 300 is what you typically would then ask the grid company to connect for you. So everything underneath there would be wasteful capacity that you connected to. So here we have illustrated if you, in this case, could use a large battery container together with the grid, you could reduce the what you take from the grid down to 100 kilowatts. So you could still have the same activity on the construction site, but then you reduce what you pull from the grid. This is peak shaving with the battery technology. There's also other measures you could take. You could avoid parallel activity and plan activities differently in order to shift the power demand. In both these cases, you could reduce costs, both in the grid rent costs, but also you could have large cost reductions in terms of grid connection, which is also very good since this high peaks here is only for the construction phase and it's a temporary need. So to sum up some of the challenges and barriers ahead onwards to zero emission construction sites. So the first one is that the grid capacity is often weak, both in terms of capacity, but also voltage. And especially when you come to rural areas, or even in the city center where it's often stressed grid, this can be a large barrier for starting to use electrical or other zero emission technology equipment. The grid connection process in itself can be challenging, expensive, and time consuming. So the grid connecting to the grid can often take up to 6 months or even longer. And when a contractor gets the contract for a construction site, they often start just weeks or a few months after they get the contract. So waiting 6 months or longer for grid connection can be a huge barrier for starting to use electrical excavators in the groundwork phase, for example. The availability of electrical machines and other equipment is also a barrier. Several of these machines are nowadays rebuilt diesel engines that they take away the engine and built it to electrical machine. So this is it's a long lead time, and it's not that good availability yet when it comes to the larger excavators, for instance. But this hopefully this will be better in the future towards 2025. Also, other equipment and infrastructure is not fully developed yet in Norway and available. Long delivery times is a challenge. Can be 1 year or even 2 years wait for having an electric excavator. And also delivery times for larger battery packs can be quite long. High cost of electrical equipment and infrastructure. So some entrepreneurs say that the cost of an electrical excavator can be up to 3 times as expensive as a normal excavator. So it's very important to have incentive schemes for this. Also, infrastructure. If you have a fast charging need far away from the power grid, this can mean that you have a larger cost to get the necessary infrastructure on site. On the other hand, you could have large savings when it comes to operations of the machines. Also, we have a too low degree of standardization on both communication, especially towards the battery technology and within the different parts of the electrical infrastructure on the construction site, and also on the charging intake and the charging plugs that we use. So we hope that we in BKK have some of the solution to these challenges. We're trying to develop infrastructure that can help and make it easier to start using electrical equipment and excavators. So we're developing mobile, scalable and modular energy solutions that we can provide temporarily out on construction sites. So we have mobile batteries that's scalable up to maybe more than 1 megawatt hour. We have different sizes tailored to different needs. Then we have the charging infrastructure, fast chargers that's put in containers, and normal chargers, both in containers and in smaller single chargers. And then we have heating solutions that can be used for temporarily drying and heating of buildings. So what we've been doing so far in this project is to develop prototypes and test them out in real life scenarios, and then redeveloping these again. So here you can see a picture of our newest battery system that's now in a testing phase in Nygårdsparken. So you can see it there if you walk past it. It's currently peak shaving a cabled excavator, so running parallel with the grid, and we also tested it off grid, so supporting the excavator only from the batteries. Here on the right side, you can see another large battery container that's currently used in supporting a crane on a construction site. Down to the right, you can see a normal charging container that's used for charging excavators up in Fjällveien. Some of you maybe walk past it. And down to the left, you can see our first prototypes of our fast chargers in containers. This one we now have in testing phase, so we used it to fast charge an electric excavator with 200 kilowatts. So if you have this kind of equipment available on construction sites, you could fast charge a large machine on up to 80%, maybe in half an hour or 40 minutes. Yeah, so I thought I shared my screen with sound. I don't know if you can hear anything.
We can hear the sound.
You can hear the sound?
Yes.
Okay, because I can't, but okay. I will play the video then.
Vi I dag fordi at vi I BKK har utviklet og laget en mobil lader. Den står nå I Fjällveien og skal lade en elektrisk gravemaskin.
Bak oss her ser vi den første elektriske gravemaskinen I denne størrelsen som levert I Bergen. Vi har bestemt oss for å investere I elektriske gravemaskiner på grunn av at vi vil være med på det grønne skiftet som nå foregår I hele landet. Lading, den håndterer vi på en ryddig måte. Der har vi gått inn I et samarbeid med BKK, der de leverer oss ladetjenesten via ladecontainere som de leverer til oss, der vi kan plugge til gravemaskinene våre elektriske biler og annet elektrisk utstyr som vi måtte ønske å lade.
Vi har tatt på oss oppgaven å bli størst på elektrifisering, og da må vi bidra med mobil.
So that was the presentation for me. Thank you for attention.